Streamlining high-availability EC2 infrastructure on AWS with Terraform and GitHub Actions. This podcast is brought to you by Business Compass, LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Automating the provisioning and management of EC2 infrastructure on AWS is critical for achieving high availability, consistency, and scalability. By leveraging infrastructure as code, IaaC, with Terraform and integrating it with a CI/CD pipeline using GitHub Actions, you can streamline the deployment process, enhance security, and minimize human error. This podcast will explore the steps to automate high-availability EC2 infrastructure on AWS, leveraging infrastructure as code, IaaC, and CI/CD pipeline for automating EC2 infrastructure provisioning on AWS infrastructure as code. IaaC allows you to define your infrastructure using code, making it easy to manage, version, and deploy. Terraform is a popular IaaC tool that supports AWS and other cloud providers. By combining Terraform with GitHub Actions, you can automate the provisioning and management of your EC2 infrastructure, ensuring consistency and repeatability. Using OpenID Connect to enhance security and avoid credential exposure. OpenID Connect, OIDC, provides a secure way to authenticate GitHub Actions with AWS without exposing long-term credentials. By configuring AWS to trust GitHub as an identity provider, you can use short-lived tokens to access AWS resources, reducing the risk of credential leakage. Defining infrastructure with Terraform configuration files. To start, you must define your infrastructure using Terraform configuration files. These files describe the resources you want to create, such as VPCs, subnets, EC2 instances, auto-scaling groups, and load balancers. Creating a VPC with public subnets. A virtual private cloud, VPC, is essential for isolating your infrastructure. In your Terraform configuration, define a VPC with public subnets to ensure your EC2 instances can communicate with the Internet. Resource: AWS_VPC main. Cedar_block equals 10.0.016. Resource: AWS_subnet public. Count equals 2. VPC_ID equals AWS_VPC.main.id. Cedar_block equals Cedar subnet. AWS_VPC.main.cedar_block. 8. Count.indexmap_public_IP_on_launch equals true. Availability_zone equals data.aws_availability_zones.available.names count.index. Launching an auto-scaling group with a launch template. Auto-scaling groups ensure your application can handle varying traffic levels by automatically adjusting the number of EC2 instances. Use a launch template to define the instance configuration. Resource: AWS_launch_template, app. Name_prefix equals app. Image_ID equals AMI0C55B159 key BFF1F0. Instance_type equals T2.micro. Resource: AWS_autoscaling_group app. Desired_capacity equals 2. Max_size equals 3. Min_size equals 1. VPC_zone_identifier equals. For subnet in AWS_subnet.public, subnet.ied launch_template. id equals AWS_launch_template.app.id. Version equals $latest. Setting up an application load balancer for traffic distribution. An application load balancer, ALB, distributes incoming traffic across multiple EC2 instances, improving availability and fault tolerance. Resource: AWS_pound, app. Name equals app_alb. Internal equals false. Load_balancer_type equals application. Security_groups equals AWS_security_group, pound.id subnets, equals, for subnet in AWS_subnet.public, subnet.id. Resource, AWS_pound_listener, app. Load_balancer_arn equals AWS_pound.app.arn. Port, equals 80. Protocol, equals, HTTP. Default_action. Type, equals forward. Target_group_arn equals AWS_pound_target_group.app.arn. Resource, AWS_pound_target_group, app. Name, equals app.tg. Port, equals 80. Protocol equals, HTTP. VPC_ID, equals AWS_VPC.main.id. Implementing security groups for VPC and load balancer. Security groups act as virtual firewalls, controlling inbound and outbound traffic. Define security groups for your VPC and ALB to restrict access. Resource, AWS_security_group, VPC. Name, equals VPCC. VPC_ID, equals AWS_VPC.main.id. Ingress, from _port, equals 0. To _port, equals 0. Protocol, equals -1. Cedar_blocks equals 0.0.0.00. Egress, from _port, equals 0. To _port, equals 0. Protocol, equals -1. Cedar_blocks equals 0.0.0.00. Resource, AWS_security_group pound. Name, equals pound.sg. VPC_ID, equals AWS_VPC.main.id. Ingress, from _port, equals 80. To _port, equals 80. Protocol, equals TCP. Cedar_blocks equals 0.0.0.00. Egress, from _port, equals 0. To _port, equals 0. Protocol, equals -1. Cedar_blocks equals 0.0.0.00. Encapsulating infrastructure configuration with Terraform modules. Terraform modules allow you to encapsulate and reuse configurations. To simplify your main configuration, create modules for standard components like VPCs, EC2 instances, and load balancers. Automating infrastructure provisioning with GitHub Actions. GitHub Actions can automate the deployment of your Terraform configurations. To define the CI/CD pipeline, create a workflow file in your GitHub repository. Configuring AWS credentials and Terraform backend. Use AWS credentials securely by configuring the OIT provider in AWS and storing secrets in GitHub. Also, configure the Terraform backend to store the state file securely. Executing Terraform commands in a workflow. Define steps in your GitHub Actions workflow to initialize Terraform, plan the changes, and apply the configuration. Name, Terraform. On, push. Branches. Main. Jobs. Deploy. Runs on Ubuntu latest. Steps. Name, checkout code. Uses, actions/checkout at v2. Name, setup Terraform. Uses, HashiCorp/setup Terraform at v1. Name, Terraform init. Run, Terraform init. Name, Terraform plan. Run, Terraform plan. Name, Terraform apply. Run, Terraform apply auto approve. Benefits of infrastructure automation, consistency, repeatability, and reduced errors. Automating infrastructure provisioning ensures consistency and repeatability and reduces the likelihood of human errors. It also allows for rapid scaling and updating of infrastructure while maintaining a reliable and secure environment. Challenges encountered: IAM permissions and user data script encoding. Some common challenges include managing IAM permissions to ensure access without over-provisioning and encoding user data scripts correctly to avoid errors during instance initialization. Conclusion: secure and scalable high-availability EC2 infrastructure on AWS. You can achieve a secure, scalable, and resilient environment by automating the provision of high-availability EC2 infrastructure on AWS using Terraform and GitHub Actions. This approach enhances productivity and ensures a consistent and reliable deployment process. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.